Good morning, pre-calculus class. So this is our last lesson in three-dimensional vectors. You have a nice little warm-up, and then in the lesson last time, we learned how to find the angle between two vectors. This time, we're going to find something called the direction angles for a three-dimensional vector or vector in space. Go ahead and do the warm-up now. Pause the video. Okay, so for the magnitude of this vector, you end up with the square root of 73, which is 8.54. And then I drew a quick sketch of the vector over 8 up 3, and that helps me making sure I get my angle correct. So the angle of this vector you find by doing the tangent is the y over the x, and inverse tangent gets you 20.6 or 21 degrees. Anytime we know the magnitude and an angle of a vector, we can write it in terms of its magnitude and its angle. One thing I left out was what is the units of this. So if it's speed, maybe it's miles per hour. This same idea is going to be used on three-dimensional vectors. Okay, when we have a vector in space, we can't just talk about its angle and standard position because you have three different axes. You have your x-axis, your y-axis, and your z-axis. So really this vector can be anywhere in space. Think of it as a sphere, and it can be going to any point on that sphere anywhere in space from the origin. So what we say is for any non-zero vector in space, we can describe its location or its direction by finding its magnitude and its three direction angles. The first direction angle we'd call alpha, the next one is beta, and the last one is gamma. And these are the angles from the positive x, y, and z axes respectively. So you actually have to find all three angles separately, and you can see that alpha is between the vector v and the positive x-axis, so v and I, which is your unit vector in the x-axis direction. And then beta is the angle between v and the positive y-axis, and gamma is between angle v and the positive z-axis. And that tells you where the vector is or where its direction is in space. Okay, so here's your formula to find these three direction angles. All the formulas are really the same, but what's different is the coefficient of the I component here for alpha, the coefficient of the J component B here for beta, and the coefficient of the C component, or the K component, which is C, here for when you find gamma. So these formulas are very similar to when we found the angle before, but we used tangent, now we use cosine. So we're going to go through an example of that in just a minute, but one important property is that when you square the cosine of the three angles, you will get back to 1. It's kind of like the Pythagorean identity, cosine squared of alpha plus sine squared of alpha equals 1, but this is in space and says cosine squared of alpha plus cosine squared of beta plus cosine squared of gamma will equal 1, all those values squared. All right, so let's do our example. I am going to slide this up. I'll do the first example and then you'll do the second problem on your own. All right, so for the first problem, we need to find the magnitude of v first, and that is the square root of 9 plus 4 plus 36, which nicely in this example is the square root of 49 or 7. Now we're going to find individually angles alpha, beta, and gamma. So the cosine of alpha equals the I component, -3, divided by the magnitude we just found of vector v. And when you use inverse cosine, you end up with an obtuse angle since this is negative, and that is 115.4 degrees. We'll do the same for beta. Cosine of beta equals the b component or j component's coefficient divided by the magnitude, inverse cosine of 2/7 returns 73.4 degrees. And lastly, gamma, the cosine of gamma equals -6, your coefficient up here, divided by the same magnitude. And you end up with gamma equals the obtuse angle 149.0 degrees. So there's our three direction cosine angles. And one thing we can do now is we can rewrite this vector in terms of its magnitude, which is 7, times its direction angles, the cosine of 115.4 degrees I, plus the cosine of beta, which is 73.4 degrees J, plus the cosine of 149.0 degrees K. And that's how you write a vector in space in terms of its magnitude and direction cosines. All right, you should pause the video here and go ahead and try to do number 2 on your own. All right, and here are your answers for the second one. You end up with alpha of 72.7 degrees, beta of 126.6, and gamma of 41.8. Feel free to draw the vector and see if it makes sense. Actually, you know what? I'll do that right now just so we can see x, y, z, and our vector. Here, let me get another color. Our vector is 2 forward, and then 4 to the left, and then up 5. 1, 2, 3, 4, 5, and our vector is here. So let's just look at these angles. So if I look at alpha, that's 72.7 degrees. And then looking at beta, that's bigger, right? That's much further over. And that is 126.6 degrees. And our last angle is not very much at all. It's coming down. And that is gamma, or 41.8 degrees. It actually looks like alpha is about the same amount as gamma, but it is up there. So that's why it's up, and it's just a little bit over for the z angle. You can also check this property up here if you wanted. It's probably easier to do it with these three numbers. So what you would do is take -3/7 and square it, and 2/7 and square it, and -6/7 and square it, and it should add up to 1. Let's just check it. The numerator is going to be 9/49 plus 4/49 plus 36/49. And we should recognize these three numbers because they went into our magnitude, and that is 49. So we can see that 49/49 is 1. Okay, these last two problems are just some practice problems. Note we kind of already talked about taking a vector, finding its magnitude and direction cosines, and rewriting it in terms of that. That's what you're going to do in problem number 1. Problem number 2, you're pretty much going to do the same thing. It's giving you a little bit of a word problem there with it. So go ahead and pause it now. Try the problems on your own, and when you unpause it, you will see the answers. All right, and here are your 2 answers for these problems. You got the first one up here, and here's the second one. Now, one thing that some kids have a problem too, if they're having a hard time getting their angles, is make sure you're in degree mode in your calculator. Also, if you're dividing by something like the square, like on the other problem from the page before, maybe you're dividing by 3√5. Be careful. You can't just say, oh, it's 2 divided by 3√5, because then you're going to be doing 2 divided by 3 times √5. So you really got to make sure you put those parentheses in when you do that division on the calculator. And if you were getting the wrong angles, maybe that's one of your mistakes. All right, that's it for the lesson. Go ahead and give the homework a try. And of course, we will talk about this and see how it went.